Hello everyone. So in last class, I was talking about the single server infinite queue length model. So we have derived various expressions. So all the derivations are, you can remember those derivations. Sometimes that may be asked in different examinations. But till now in mock-out, I haven't seen any question, such question like derivation of the formulas. Like you see uh, in this problem here, utilization factor. So already we have solved other many problems on this topic. Single server infinite queue length model. The notation is MM1 FCFS infinite. Okay, so all the things in the last class, it just refer the last class and see what are the meaning of all these notations are. So we have derived that utilization factor is known as rho, which is equal to lambda by mu. This rho is also known as expected number of customers getting served. Expected number of customers getting served. Okay, so this is rho value. Okay, so probability that there is no customer in the system. So probability that is denoted by P naught. Zero customers, so P naught, and that is given by 1 minus rho, means there is no service. So this is the probability of service, that is rho. So if there is no customer means no service. So what is the probability of no service? That is 1 minus rho. Now probability of n customers in the system. So that is Pn, denoted by Pn, and that is given by P naught into rho to the power n, where P naught is 1 minus rho. Clear? Now expected length of the system. So length of system, LS, is denoted, it is given by the expression which we got is rho upon 1 minus rho. Clear? And expected number of, okay, expected length of Q. So it is given by, so LS, just you have to remember LS expression. LS is equal to rho by 1 minus rho. And expected length of Q, now you can calculate from LS. So Q and system, what is the difference? So in the system, Q length plus the customers who are getting served, both are included. So in LS, actually length of Q is included and plus the customers getting served is also included. So LQ plus rho. So that is, it is denoted by LQ. So LS can be written as LQ plus rho, where rho is expected number of customers getting served. So actually you see, if you see the system, then it's like this one. See, this is the queue, and here is the server who is giving service, and there is one customer here, he is getting served. Okay, this is the customer. So this is denoted by rho. Okay, so and this is the queue length, and this whole included the queue length plus the customer getting service is known as system. So length of the system will be equal to length of queue plus the customer getting service. So LQ plus rho. So that's why LQ can be written as LS minus rho. Clear? Now expected waiting time in the system means WS. waiting time is denoted by this, and the formula is ls divided by lambda, and expected waiting time in the queue is given by lq upon lambda. Actually these are known as Little's equation given by him. So this is Little's equation. Okay, so there is no need of going for the derivations and all how these formulas have come. Just remember that this is the expression from the Little's equation, and we can calculate through this expression. Okay, so these are the formulas which we will use. That's all. If you can remember these formulas, you can solve all types of problems in single server infinite queue length model. So there is nothing to worry about the even derivations. If you don't know, just remember these formulas. What are those? Probability of no customer in the system, probability of n customers in the system, expected length of the system, expected length of the queue, expected waiting time in the system, expected waiting time in the queue. So let us solve one problem, and then we will see the application of all these formulas. Okay, so there is an example here. It's written that customer arrive at a clinic at a rate of 8 per hour Poisson's arrival. That means the arrival is following Poisson distribution.
Could you try again?
And the doctor can serve at a rate of 9 per hour, that is exponential.
I didn't catch that. Could you try again?
Clear? So both are following which kind of distribution? M. Poisson arrival means M, denoted by M, and exponential service rate, that is also M. And how many server are there? Means doctor is there, so only one doctor is there, so 1. So this is the model MM1. And how the service is happening? First come first serve, correct? When you arrive to the doctor, it is actually first come first serve. And like what is the length, what is the capacity of this clinic? So obviously it can serve as many customers or as many patients it will come, they can be served, so it is infinite. And the what is the population? So that is also infinite. So this is the model. Okay, so if this one is confirmed, now we can apply all the formulas which we have seen in the last slide. Clear? So now what is the probability that a customer does not join the queue and walks into the doctor's room directly? Means he has not to wait, actually he can directly go into the doctor's room. So how that means what? That means there is no person in the system when he comes, and there is no person in the system. Clear? So that if there is no person in the system, the probability of no person in the system is P naught, and that is given by 1 minus rho. Clear? So can we tell what is rho? That is lambda upon mu. What is lambda? 1 minus lambda is 8 and mu is 9, that is 1 by 9, and it comes 0.111 something like that. So this is the means 11% chance is there that the customer which is coming he does not have to join the queue, just he can directly go and see the doctor. So this is the first question. B. What is the probability that there is no queue? Okay, so no queue, that means what? That there is no person in the system? No, actually if there is no queue means probability of, just write down, probability of no queue. सो हो सकता है ना कि या तो एक भी कस्टमर वहाँ पे नहीं हो, और या फिर हो सकता है एक कस्टमर जो है उसको वो सर्विस करवा रहा है, so he is already seeing the doctor, he is not in the queue. So if there is no queue, that doesn't mean that there is no one in the system. Clear? There may be one customer who is getting served. So this is the we can say this is the complete probability. So this will be p naught. P naught is 1 minus rho plus what is this p1. So we know that pn is equal to p naught into rho to the power n. So p1 is equal to p naught into rho. So p naught into rho, so p naught is 1 minus rho into rho. So we have already calculated 1 minus rho, so this is this much plus 1 minus rho is equal to 0.111 into just 1 minus this much. How much it will be? 0.8889. Yeah, so how much it will come? Let me calculate. 0.111 this comes 0.2096. So this is the value that there is no person in the queue, that is 0.022096. Now see the third question. See, what is the probability that there are 10 customers in the system? That means he is asking about p10. So p10 simple, very easy. So p naught into rho to the power 10. So p naught is 0.111 into rho. Rho value is 8 by 9, or you can say 0.889 to the power 10. So how much is that? There are no 10 customers in the system, that is 03422. It's not asking about 10 customers in the queue, it's asking about 10 customers in the system. There is no way to calculate that how many customers are in the queue until unless it is not given that how many persons are getting served. Clear? So this is always asked 10 customers in the system. Okay, so that is, and all the formulas, pn is actually its n is n customers in the system. D, what is the expected number in the system? That means length of system. So we have already have the formula, rho divided by 1 minus rho, that is 0.889 divided by 0.111. This is coming around 8, around 8. So this is 8 value. Yeah. Now E, expected waiting time, that means WQ. He is asking about waiting time in the queue. So that comes LQ divided by lambda. LQ is LS minus rho divided by lambda. So LS is 8, rho is 8 by 9, 8 by 9, and divided by lambda. Lambda is 8. So how much is this one? 8 by 9. Okay, so the value comes is 8 by 9, that is 0.889. So this is the this much expected waiting time, that is 0.889. It will be in hour. Clear? So this is the solution of the problem. Okay, so let us see. So we have already seen finite, that is infinite queue length. Now we will see single server, but the queue length is finite. That means you can say that the system capacity is limited, just like the previous example which we have seen of doctor, the clinic. So there may be some restriction that in a day doctor will be able to see only 50 customers or 50 patients. So that means the queue length is finite. So as soon as the customers or patients number is 50, it is reached, then if the 51 or 51st customer, if he arrives, then he cannot join the system, he has to leave, okay, for the next day. Is it clear? So that is known as single server but finite queue length model. So it is denoted in this way: MM1 FCFS n delta infinite. So now utilization factor in as similar, rho is equal to lambda upon mu. There is no change in it. Probability of no customer in the system. Okay, so probability that there is no customer in the system. So that is P naught 1 minus rho. Probability of n customers in the system, same, Pn is equal to P naught rho to the power n. Expected length of the system, Ls. Now here there will be change. Okay, so let us derive that expression, or you can just remember, there is no problem in okay, let us derive it, there is no problem. I'll derive the problem, this expression. Okay, so let's see what happens when the system is having finite length. So let's suppose n is the number of, or you can say the capacity of system. Okay, so that means what? That n plus 1 customer, n plus first customer, he will not be joining the system. Okay, so obviously the number of customers in the system, we have to calculate number of customers in the system. Okay, it can be from 0 to n, anything. Clear? So can be 0 to n. Okay, so that means what? Probability of 0, probability of 1 customer, probability of 2 customers, like that. Probability of n customer is 1. Now here this n is not infinite, that is fixed n. Okay, so because there can never be more than n customers in the system, so the sum of all the probability will be 1. So we know that, okay, that I have done mistake. The expression for P naught is equal to I have told 1 minus rho. That is not correct. That is for infinite queue length model, but here the expression will change. Let us see this p naught into rho plus this can be p naught into rho square plus p naught into rho to the power n is equal to 1. So p naught is taken out and 1 plus rho square and rho to the power n is equal to 1. From here we can write this is the sum of, now look at this, rho, value of rho can be anything. Earlier in infinite queue length model it was expected that rho should be less than 1, but here rho can be less than 1, it can be equal to 1, it can be greater than 1. So we don't know, it can accept any value, because now I have told already in the previous model that there is a, if the queue length is finite, okay, it's fixed, then rho can be greater than 1 also. Why I told that? Because there is a situation that see here in this case, because it is a finite queue length model, so if n customers have already joined, okay, even if rho is greater than 1, that means what? Lambda by mu is greater than 1, that means lambda is greater than mu, that means what? Arrival is more and service rate is less, that means what? So arrival is more, people are coming more frequently, but service is little bit slow. So if the customers are coming and the queue length is infinite, what will happen? That the customer who is not served, it will start increasing, after every unit time. Let's suppose customers are coming 10 per hour, but they are served 8 per hour. So every hour 2 customers are not served. So there is a chance infinite queue length means that the customers will never be served. Some customers will be left eternally. There is a chances of that. But in case if the lambda is 8 per hour, the arrival rate is less, but service rate is more. So what will happen? In case in some duration, let's suppose there is no arrival, because it is probability, no? So if there is no arrival, in that case, in case if there is no arrival but service rate is 10, so it may manage. But in this case, because the every time it is increasing, so there is a chance that some customers are left of any service, they will not be served. But in case of finite queue length model, n customers, we know that this is the capacity, so I can serve in a day. Let's suppose doctor, he knows that 50 patients he can serve in a day. So whether he serves in a slow pace or fast pace, it doesn't matter, because he can serve 50 customers in a day. So the customer who have already joined in the system, they will be served anyhow. So it does not this term, or if it is greater than 1, less than 1, equal to 1, it doesn't matter. Okay, so now if it is not less than 1, if it is anything, then we can apply general geometric progression summation. So that will be rho to the power n plus 1 minus 1 divided by rho minus 1. In case if rho is greater than 1, if rho is less than 1, 1 minus rho to the power n plus 1 divided by 1 minus rho. Same thing. So here P naught is equal to rho minus 1 divided by rho to the power n plus 1 minus 1. This is the formula for P naught. And Pn, obviously it will be P naught into rho to the power n. This is another formula. So just take this. Okay, so now what will be the value of ls? Okay, so let us see the value of ls. So ls is equal to, I'll directly write the expression. Okay, so it's actually the number of customers in the system, so that is denoted by number of customers in the system is probability. Okay, so this one is the expression for number of customers in the system. In case if this n is infinite, then that will be infinite Q length model. So here we can write this is P naught into rho to the power n summation of it, and P naught if we take out, and if we take out rho also, one rho, then it will be n rho to the power n minus 1, n is equal to 0 to n. Okay, so this is derivative of rho to the power n. So we can write n is equal to 0 n rho to the power n. Now what is this? So derivative of rho to the power n, already we have seen that P naught is equal to what was there, rho minus 1 divided by rho to the power n plus 1 minus 1. Is it clear? So here you just calculate. This is rho to the power n means rho to the power 0, rho to the power 1, rho to the power 2, something like that up to rho to the power n. This is a geometric progression, so just write down this one. This will be rho to the power n plus 1 minus 1 divided by rho to the power n. Now derivative of this one, can you calculate? Rho P naught, derivative of this into this minus derivative of this into this divided by derivative of denominator square, sorry, not derivative. So just write the expression. This is left, and derivative of this will be n plus 1 into rho to the power n minus this will be left. Oh, it's getting congested. Wait a minute, I'll just clean it. Look at this one. So we can write rho P naught, this will be rho minus 1, and derivative of this is n plus 1 rho to the power n minus rho to the power n plus 1 minus 1 into, what is the derivative of this? This is 1 divided by rho minus 1 to the power 2. Okay, now what is P naught value? P naught is, we have derived rho into rho minus 1 divided by rho to the power n plus 1 minus 1. And what is this one? If we expand, what is going to come? So rho into n into rho to the power n is equal to n rho to the power n plus 1. Clear? Rho 1 oh, okay, so this will be n plus 1 into this much. Okay, and this is minus n plus 1 into rho to the power n, and here is this minus rho to the power n plus 1 minus minus plus 1, and divided by rho to the power rho minus 1 square. So how much is this? This is cancelled 1, So it will be left divided by rho minus 1, and down is this one. Okay, it's a little bit lengthy expression, but nothing to worry about. This is rho to the power n plus 1, and this is also rho to the power n plus 1, so it will remain rho to the n into rho to the power n plus 1 minus n plus 1 into rho to the power n plus 1 into this. Okay, so this is the expression, final expression for the LS. So earlier we have seen in the infinite queue length model, LS is equal to rho divided by rho minus 1. Okay, but here, or it was actually rho divided by 1 minus rho. Rather, here we are having this one. Now, if rho is less than 1, what will happen? If rho is, if you use this expression also, there is no problem in it. But see here, because this one, it will come negative, and this also will come negative, 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 positive. So better you can sweep it like 1 minus rho and 1 minus rho to the power n plus 1. Okay, so in both the cases it will be safe if it is less than 1. Clear? So this expression is valid for all types of rho. So we have calculated LS. LQ we know. LQ is, what is LQ? LQ is LS minus rho. Okay, but here there is some twist. This formula will not be used. So let us see what will happen. So I'll remove all the things. Look at this. Already we have seen that as soon as the number of customer reaches to n, capital N, then what will happen? There will be persons, they will not join. So the probability that the customer arriving will be forced to leave the system, or you can say forced to, they are not allowed to join the system. Actually, this will be the correct sentence. Will not be allowed. Will not be allowed to join. Force, actually they are forced to leave the system. That is correct. So that will be Pn. Okay, because that is the probability that there are n customers, and that will be the probability that the customer will not join the system. So that is Pn, and we know what is Pn, P naught into rho to the power n. Okay, now this is the probability that customer arriving will not join the system. That means how many customers are not joining the system? Okay, so expected number of customers of arrivals not joining the system will be how much? Probability into expected number of customers arriving. So that is lambda into Pn. Clear? So can we calculate effective number of arrival? So that will be less. So effective arrival, that is equal to lambda minus lambda Pn, and we denote it as lambda effective. So this will be used for further calculations. Okay, so this lambda effective is required. Okay, so we have calculated LS and that is equal to row upon 1 minus row, or row minus 1 minus row, write it. And bottom there was one more expression, 1 minus row to the power n plus 1. On the top, what was the expression? N into row to the power n plus 1 minus n plus 1 row to the power n plus 1. This was the expression. Okay, LQ will be how much? LS minus lambda effective. LQ will be less than LS, so row effective, no, row effective, where row effective will be equal to lambda effective by mu. What is WS? So WS is equal to LS divided by lambda effective, and what is WQ? Is LS divided by LQ divided by lambda effective. So these are the expressions we have to remember, and we will solve one question now. So same question, previous one. What we are going to do is we are going to restrict the number of customers, that is we are keeping n is equal to 10. Now all the values, see, there was lambda, that was 8 per hour, mu was 9 per hour. Question is asked the probability that the server is free. Okay, so server is free, there is no customer in the system, P naught. What is the expression for P naught? So server is free, first question. So P naught, what was the expression? So the expression was row to the power n plus 1, no, it was reverse of it. Clear? So just first of all find out the row, then is it greater than or less than 1? 8y9, it's less than 1. So which type of equation we will use? This one. Okay, if it is greater than 1, we will use row minus 1 divided by row to the power n plus 1 minus 1. Clear? So just calculate this, how much is 1 by 9 above, and this will be 1 minus 8y9 to the power n plus 1, that is 11. That is how much? It is coming 0.153. That means 50% time the server will be free. Earlier in the last example, when there was infinite queue model, in that server was free for 11% time, but here 15%. So this is a loss in the terms of the clinic, because server is free for more times. Okay, next question, the probability that a person entering does not see a queue. So no queue means P naught plus P1. या तो कोई कस्टमर नहीं है, या फिर एक कस्टमर है वो भी सर्विस ले रहा है. तो P naught का वैल्यू तो पता है हमें, 0.153 प्लस P1 is row into P naught. So that is 1 plus row value is 8y9, that is 0.889 into 0.153. Calculate this. .288. Oh, very nice. Actually this is also increased. Last time it was 20%. You just go and check in case of infinite queue model, this was 20%. Now it has increased to 28%. Means now the customer who is arriving, he has more chance to see that there is no queue. Let us see next question. The probability of an entering person forced to leave the queue without joining it. So arrival forced to leave, that is the probability of arrival forced to leave without joining, so just write that joining, that is we have seen Pn, that's the probability. Okay, so how much is that? Pn, that is p naught into rho to the power n. P naught value has come 0.153 into rho, that is 0.889 to the power n. N is 10. How much is this? 0.153 into it is coming 0.047. This is also increased. D, what is the expected number in the system? LS. Oh, big expression. So what is that? Rho divided by 1 minus rho, ये तो फिक्स है, ठीक है, ये हमेशा याद रखना. जैसे ही expected number of customer in the system is asked, first write the expression of infinite model, after that you have to add. तो आपको याद होगा, नीचे में तो पता है 1 minus ना, 1 minus rho to the power n plus 1, this is added down, and here just remember that first rho to the power n plus 1, इसके आगे n लगाओ, फिर उसके बाद rho to the power n, इसके आगे क्या लगाना है? n plus 1, but I have a negative here, r plus 1. So this is the expression, and calculate this, and it will take a time, so please find out that what is the value. Then E is expected waiting time in the queue, that is WQ. So how much is that? That will be LQ divided by rho, and that is LS minus rho divided by rho. Oh, sorry, here is some mistake. Yeah, here it will be lambda effective. You have to calculate lambda effective. So what is the lambda effective here? And one more thing, this is okay, so we need to go for rho. Here rho effective we have to take. Okay, so first of all lambda effective is equal to how much? Lambda into lambda minus lambda into Pn, that was the effective. So Pn we have calculated this much, and lambda is 8, so 8 into 1 minus 0.047, and that comes something 1 minus answer into 8, that is 7.62. Now you can put it here and calculate WQ. Okay, so we will stop here and try to solve some of the problems which are given in the quiz. Thank you very much.